third lecture of beta decay. So today we are going to study what were the difficulties in beta particle spectra. So there was difficulty in conservation of energy and second in conservation of angular momentum. So let us see one by one. So first one is conservation of energy. So in beta decay, a parent nucleus with a definite energy state emits an electron and leaves a product nucleus which is also in a definite energy state. So the energy of the emitted electron, however, it is not equals to the difference between the energy of the nucleus before and after emission. We know that we have a parent nucleus and an electron is emitted and we got a daughter nucleus. So obviously energy of electron, it should be equal to the difference between the energy of the parent nucleus and daughter nucleus, but it is not happening. So it is found to have any value between 0 and the maximum value of the continuous spectrum. So why this is happening? Second, the average energy of the emitted particle is only about 1/3 of the maximum energy. Therefore, the principle of conservation of energy seems to be violated in the beta decay process. Now, when we talk about intrinsic spin of nucleons, a proton, a neutron, and an electron have intrinsic spins. And the value of the spin angular momentum for each of these particles, proton, neutron, and electron, it is half h cross. Hence, there is a total spin angular momentum for the nucleus, which is given by the vectorial addition of the spin angular momenta of the protons and the neutrons contained in the nucleus. Hence, for a nucleus consisting of even number of nucleons in the sense neutrons and protons together in a nucleus, they are called as nucleons. Suppose I have a nucleus with even nucleons, then in that case the total spin angular momentum should be even multiple of half h cross. And if the nucleon number it is odd, then the total spin should be an odd multiple of h cross. That is what should happen ideally. In beta decay, an electron with spin half h cross is emitted by the nucleus. Hence, the total spin angular momentum of the even a nucleus should become odd, because half h cross, it is the spin of electron which has and that electron has come out of the nucleus. So if suppose I have 6 h cross 6 by 2 h cross, it is the spin of the nucleus, and half h cross has come out, so obviously it will be odd. And if an odd a nucleus is there and an electron has come out, then it should be even multiple of half h cross. However, when we look at the beta decay process, the total of number of nucleons do not change. That is, mass number A remains constant. Hence, the even multiple must remain even and odd multiple odd after decay. Thus, as explained above, there were difficulties about the conservation of energy and the conservation of angular momentum in beta decay. Now, how we can find out the solution, that we are going to study in the next lecture. Thank you so much.